Hey guys, I have your notes here for section 5.3 day 1, and what we're going to be doing in this section over the course of 2 days is looking at more trig formulas to help us find sine, cosine, and tangent fractions for an angle that is not on our sheet of common angles. Now, these are the hardest of the formulas that you're going to encounter. So the formulas that you encountered in our previous section were easier. They were the sum and difference formulas. These are double and half angle formulas. The half angle formulas is usually what causes people the most grief, because there's kind of two different angles to keep track of. Overview. Here's what it's going to help us do. It's going to help us find sine, cosine, and tangent fractions for an angle not on our common angle sheet, but an angle that's half of one of our common angles. For example, this formula will help me get my sine fraction for a 15-degree angle. 15 degrees is not on here. The smallest angle that's on here is 30. So here's the cool thing. If I want sine of 15 degrees, the cool thing is 15 is 30 cut in half. And we can do all kinds of things with a 30-degree angle because it's one of our common angles. So that's what's going to help us do is if we need an angle and we know that it's half of one of our common angles, then we can get the sine, cosine, or tangent fraction for it. The double angle formulas. We're going to be using these without really talking specific angle measures. This isn't helpful in the way that this is helpful. This is helpful to find sine, cosine, and tangent of an angle that's not a common angle because it's half of a common angle. This isn't helpful because anytime we double a common angle, we get another common angle. So yes, we're going to use these formulas, but we're not always going to have an actual angle measure to work with. Whereas here, we often will have an actual angle measure to work with. So, when we do this formula to find sine of an angle that's not a common angle, we're going to use this formula. Now, the cool thing is, the angle that we're using in the formula is a common angle, something that we can do sine, cosine, or tangent on. So we're going to apply this formula, and it's going to be up to us at the very end of our problem to decide, do we want the positive root or the negative root for our final answer? And I'll show you how to do that. When we use this formula, notice that the angle that we're using throughout the formula is a common angle. And it's going to be up to us after we finish the problem, we're getting ready to circle our answer. It's going to be up to us to choose, do we want to use the positive root or the negative root to represent our final answer, which is going to be a cosine fraction. Tangent. Again, this gets you tangent of an angle that's not a common angle, but it could be expressed as a common angle cut in half. Now, the cool thing about this is you've got 3 different choices on which formula to use. You can use this formula, which involves a radical and a decision. You can use this formula, no radical, no decision about positive or negative. You're going to have to use the cosine fraction as well as the sine fraction for a common angle. But you don't get to choose positive or negative. However this works out, if it works out to be a positive fraction, that's the way the answer was supposed to be. If it works out to be a negative fraction, that's the way the answer was supposed to be. And same with this one. You could choose to use this formula. If it works out to be a positive answer, awesome. If it works out to be a negative answer, awesome. If you didn't mess it up, then the answer works out the way it's supposed to be. Okay, so let's try some. Again, I've already got these written out for you, so you just probably want to pause the video so that you can write and catch up with me. We're trying to do a tangent of 5 pi over 8. This is in radians. 5 pi over 8 is not on here. So, but I think it might be half of one of our angles that's on here. Let's find out. So I think, this angle that's in my problem, my original angle, I'm calling it theta. And I've got it in blue. Same way I did up in the formulas up here. I've got it in blue, okay? I'm going to call it theta. Now, I think this angle is half of a common angle. I think if I take a common angle and cut it in half, I can get the angle that's in my problem. How do I figure out what this common angle is? Not hard. Here's what I'm going to do. This is theta. This is the angle in the problem. I think that it's going to equal some common angle divided by 2. I'm going to cross multiply. I'm going to go 8 times x equals 2 times 5 pi. I'm going to divide both sides by 8. 10 pi over 8, that doesn't sound familiar. Does that sound familiar to you? Nope. Reduce it. 5 pi over 4. Aha. 5 pi over 4 is right here in quadrant 3. This is a common angle. This is the pink angle, the common angle that I'm going to use throughout my formula. So watch what I do. The problem was tangent of 5 pi over 8. That's still going to be part of my final answer. That's what I'm trying to find, tangent of 5 pi over 8. But in order to find it, I'm going to use the formula, and 5 pi over 4 is my common angle. Okay? So tangent of this is the same thing as tangent of 5 pi over 4 cut in half. These represent the same things. Now, this is the way I'm going to set up my formula. Here's what the formula looks like. It says in your formula, you're no longer looking at this. Why? What good would it do? We know nothing about it. We don't know sine or cosine or tangent. Don't look at this anymore. This is the new angle that I want to look at. This is my common angle. This is the way the formula is set up. I'm copying it down, I'm copying it down, I'm copying it down, and it says this is the angle that you put here and here. Why? It's the way the formula is set up. Also, we can do sine and cosine on 5 pi over 4. It's a common angle. So, here we go. Let's start doing the work here. So what I did is I evaluated cosine of 5 pi over 4. This right here results in a fraction. So here I go. You should be able to do this quickly, but just in case you've forgotten, let me kind of go over it slowly once with you. 5 pi over 4, my reference angle is pi over 4. My cosine fraction for pi over 4 is radical 2 over 2. However, this is in quadrant 3, ASTC. This cosine fraction that I sub into my formula ought to be negative because it's in quadrant, because this is in quadrant 3. So I've got 1 minus this new fraction, okay, I'll deal with this in a minute, over sine of 5 pi over 4. Well, now I need to replace this with a fraction. So, same process, reference angle, pi over 4. Fraction, radical 2 over 2. Quadrant 3, negative. Now, this is what you kind of encountered last section. We got 2 things to deal with here. One is, we have miniature green fractions within a fraction. Let's get rid of that. That's just messy. Also, we are going to have a radical in our denominator. We have to fix that too. But first of all, get rid of the fractions and make this way less complicated for yourself. Get rid of the fractions. So, I changed minus and negative to plus. That's still negative. This is how I get rid of my fractions. My denominators were 2. So I'm going to multiply my entire numerator by 2 and my entire denominator by 2. Don't forget to distribute. So I got 2 times 1. I got 2 times this fraction. Well, 2 times this fraction, my 2's are going to cancel, and I'm just left with this radical. Same concept down here. Okay, this is what, see, doesn't this look better than the one before it with those little miniature green fractions in there? Now, let's fix the radical on the bottom. So I can multiply by its complex conjugate, so negative radical 2 over negative radical 2. Distribute on the top, multiply flat out on the bottom. That's what you get. We're almost there. Everything has a 2 in it. Pull it out. Actually, I pulled out a negative 2. So pulled out a negative 2. I don't know why I did that, but I did. And then canceled my 2's. And that's what I got. So, why were we doing this? What were we trying to find? Remember the original problem said find the tangent fraction for 5 pi over 8? That's what we did. We found the tangent fraction for 5 pi over 8. It actually contains a radical, and that's okay. Tangent of 5 pi over 8 is this. Now, here's what's cool. You can check this on your calculator. So grab your calculator. Hopefully it's scientific, because that's what you should be using throughout this chapter. Make sure you're in radians. I'm in radians. And I'm going to go tangent 5 pi divided by 8. And I get, not this, I get a decimal. But I wonder if my decimal is the same. Negative 2.412, negative 0.2, whatever. I wonder what this is as a decimal. Negative radical 2 minus 1. Oh, hey, it's the same decimal. Why couldn't I have just typed it in my calculator in the first place and answered as a decimal? Because it wanted exact. It wanted exact, not rounded. Okay, let's try another one. Very similar. The next one's asking for cosine. So, here is the original problem. Let's find cosine of 11 pi over 12. This is theta. This is an angle that is not on our sheet of common angles, but we're going to find the cosine fraction for it. So, this is theta. Remember, I think theta can be written as a common angle cut in half. This right here is like the key to the whole problem. This can be written as a common angle cut in half. Wonder what the common angle is that I'm supposed to use. Let's find out. Theta equals common angle divided by 2. Cross multiply. 12x, 22 pi. Divide both sides by 12. I get 22 pi over 12. That doesn't sound familiar. That doesn't sound like a common angle. Reduce it. Aha, that's a common angle. 11 pi over 6. That's in quadrant 4. 11 pi over 6. That's the angle I'm going to use in my problem, in my formula. So this is what it's all about, but I can't use it. Let's change it to this. Okay? So here's how the formula looks. It says cosine of this over 2 equals. And it says take this angle and sub it in here. Notice there's a plus or minus out there. We'll deal with that later. Right now, I'm going to work on finding the fraction for cosine of 11 pi over 6. Ready? 11 pi over 6. Reference angle is pi over 6. Fraction, radical 3 over 2. Quadrant 4, ASTC, ooh, positive. Positive radical 3 over 2, sub it in. So right here, this green cloud became my cosine fraction, and it was positive, so that stayed a plus. Now here's what I'm going to do. Again, I've got a miniature fraction within a fraction under a radical. So I'm going to fix my fraction first. Notice I extended my radical just a little bit, and I just came in here and I tucked under, and I said I'm going to tuck under, and this is perfectly legal. I'm going to multiply this fraction by 2 over 2. Perfectly legal. I'm under the radical. Multiply by 2 over 2. Distribute. Multiply flat out across the bottom. I'm still under the radical. This is going to look weird to you. You have a radical inside a radical. You might not have ever seen that before. It's okay. Now, can 2 plus radical 3 square root nicely? The answer is no. Let's keep it under a radical. Can 4 square root nicely? Yes. So just write your radical on top, don't extend it to the bottom, and make this a 2. See, radical is only up on top because I square rooted the bottom, which used to be 4. Now it's time to choose. Do you want the positive version or the negative version? Well, let me start writing my answer. I'm going to write my answer. Pretend you didn't see that. I'm going to start writing my answer. The original problem said, let's do the cosine fraction for this angle that's not a common angle. This is the answer that I got, but it's either positive or negative, and I'm not sure which. Well, where is this angle? This angle is just under 12 pi over 12, which puts us in quadrant 2. Tell me something about cosine fractions in quadrant 2. Yep. They are negative. So we're going to choose at the very end. When we're ready to circle our answer, that's when we choose. Because you know what? I want to make sure you're choosing based on this angle, the original, the answer to your problem. I want you to choose based on this angle, not that angle. So we're going to wait till the very end when we're circling our answer to choose which sign to go with. Okay, here's another one, but it's in degrees. You know what's funny? At the beginning of the semester, I said, in a few months from now, some of you are going to prefer radians over degrees. You've known degrees like your whole life. Like all through elementary school, you started learning degrees for angles. And now all of a sudden, we're throwing radians out at you. And in just a couple of short months, some of you are better working with radians than you are with degrees. It's kind of funny. And if you plan on going on to calculus, I hope that you're better at radians than you are in degrees, because calculus doesn't work in degrees. So we use radians the whole time. All right, here we go. 105. Not on here. I think that 105 is going to be half of something. So this is the relationship that I use. Remember, I'm calling this one my theta. So 105 is something cut in half. Now, many of you just know automatically what the angle is, and some of you don't. So let me go through and do the math with you. I'm going to cross multiply. 1 times x equals 2 times 105. X ends up to be 210 degrees. And guess what? 210 degrees is right there, quadrant 3. It's a common angle. So I'm going to write my formula using this common angle. Here I go. This is my common angle. It goes here. Wrote out my formula. I'm going to work on finding the cosine fraction for 210. Holy moly. 210 is 30 away from 180. So 210, yeah. Reference angle is 30. Man, it's hard for me to think in degrees. Reference angle is 30. Cosine fraction is radical 3 over 2. So this green cloud is going to be replaced with radical 3 over 2, but negative, quadrant 3. Fix it. Now, miniature fraction within a fraction. Let's get rid of it. So I'm going to tuck under my radical sign, and I'm going to multiply it inside in this fraction by 2 over 2. Perfectly legal. Distribute, multiply across the bottom. Ooh. There you go. Can the top square root nicely? No. Can the bottom square root nicely? Yes. Let's square root it and don't extend this down to your denominator. Don't even think about canceling illegally. There's 2 reasons why this cancel here is illegal. One is the 2 is under a radical and this one's not. That's one reason it's illegal. The other reason is this is a binomial. These are attached with addition. You can't cancel. Choose. It's time to choose. Do we want the positive version of this fraction or do we want the negative version of this fraction? So here I go. I'm getting ready to write my answer. And the original problem asked, what is the sine fraction for 105 degrees? And I'm saying, here's my answer. Here's my sine fraction for 105 degrees. 105. Which quadrant is it in? Quadrant 2. So are sine fractions positive or negative in quadrant 2? They are positive. So I could write a plus here, but that's not necessary. I'm just going to leave it like that, circle it, and there's my answer. Okay, next one. Use formulas to rewrite each of the following. So we're going to use formulas to replace, and we're just going to keep going and going and going until we can't go anymore. It's just telling us to rewrite it. So here I go. The first thing I did was, I keep saying this, y'all aren't super good at recognizing what this means. So I like to write sine and then my angle and then put the whole thing in parentheses. So I copied this and then I put sine of my angle in parentheses and put a squared on the outside. Now, this is a thing. I highlighted it yellow because it's on my formula sheet. Go to your formula sheet and let's find out what to replace this with. That's what I replaced it with from my formula sheet. Ready? Let's simplify using order of operations. So, parentheses, exponents. Let's do this exponent. What do I get when I square a radical? Well, wait. Am I squaring the positive version of the radical or am I squaring the negative version of the radical? Doesn't matter. Positive times a positive is a positive. A negative times a negative is a negative. Either way, we're going to get the same thing. So when I square the radical falls off. So same, parentheses, only this cancels this out. Right? It's exactly the same, only the plus and minus is gone and the radical is gone. Now, order of operations. Don't do this first. Do the multiplying first. How do you multiply 2 to this? Well, I'm hoping you reduce first. I'm hoping you reduce this 2 with this 2. Reducing. Crossing them out. I crossed them out. Distribute your negative. Collect like terms. Oops. And I just am left with cosine x. That's the last thing that I can do. I rewrote it and simplified it. Moving on. Same deal here. Careful. Sine plus cosine. Be careful. You can't stick a 2 on each of these. This is a binomial. If you wanted to square this binomial, you would have to FOIL. So don't even think about sticking a 2 on here. Also, don't even think about replacing sine of x plus cosine of x with 1, because in order to do that, they have to be squared. So let's work on this. This should look kind of familiar to you. It's a formula on the front of your page. Let's replace this with its formula. So, same. Replaced this with its formula. Now, I'm going to square this. I'm going to FOIL it. I'm going to go first, outer, inner, last. First, outer plus inner. Last. Same. Collect like terms. This positive 2 sine cosine cancels with this negative 2 sine cosine. And I'm left with this term and this term. And y'all know what that is. It's 1. Okay, last one. I don't know if you have writing on your triangle or not, but if you don't have writing on your triangle, set it up like this. It's supposed to already kind of be set up for you. So, this is an angle. It is an acute angle. How do I know that? Because this angle already takes up 90 degrees out of our 180. This is an acute angle. Is it a common angle? I don't think so. I'm not sure. Well, I am sure, but let's just pretend I don't think so. So, I don't care what it is, but I can, based on this information, I can make a sine fraction and a cosine fraction and a tangent fraction based on my drawing for this acute angle. Now, here's what the problem says. If I took the angle in my triangle and I doubled it, but wait, I don't know what the angle was. That's okay, you don't have to know what it was. Whatever it was, double it. What would the new cosine fraction be? I'll give you a hint. You can't just double the cosine fraction. The angle, whatever it was acute. Double it. What's the new cosine fraction for the new angle? You have a formula for that. The formula says, do this. Okay, y'all aren't very good at that. Let me rewrite it. The formula says, do this. Okay? We're going to take our existing cosine fraction for our existing angle called theta. We're going to square it times by 2 and subtract 1. That's going to get us our cosine fraction for a bigger angle than what was original. All right, so you know how I showed you those fractions over there? Grab the cosine one and sub it in. Grab the cosine one and sub it in. Order of operations, square it. Multiply. By the way, when it says multiply by 2, we're multiplying by 2 over 1, okay? So that's an 18 and that stays a 25. Subtract. Either get you a common denominator or get you a scientific calculator, one or the other. Subtract. And I get negative 7/25. Wait, what is that? Negative 7, what am I finding? I'm finding cosine of 2 theta. That was the original question. Remember theta that was up here that was acute? I don't want cosine of that one. I really want cosine of double that one. Well, if we take an angle in quadrant 1 and we double it, I think we end up in quadrant 2, don't you? Take an acute angle, double it. We just made it bigger. And depending on how big it was, it's probably going to be, it could be in quadrant 2. Is it okay to say that my cosine fraction for the bigger angle, the one that was doubled, is negative? Yeah. The angle was bigger than 45 degrees in the first place. How do I know that? Because when I doubled it, it had to go into quadrant 2. Because that had to be negative. Anyway, that's just having your brain work a little bit. Next one. Use the formula. This time, I want to do the tangent fraction for not the angle in the picture, half of the angle in the picture. It was already acute. Now, divide it by 2 and make it even smaller. Now, what's the tangent fraction? That's what we're doing. So, here's the formula. And it says use this angle. Use the angle. So I'm going to grab my cosine fraction, which is over there in purple. I'm going to grab my sine fraction, which was over there in purple. I'm going to get rid of the fractions by multiplying everything by 5. And I do the math. And I ended up finding, what'd I end up finding? I ended up finding tangent of theta over 2. There we go. And I get positive 1/2. So it was quadrant 1. All right, that's it. Good luck. Try to keep those angles straight. The original angle versus the angle you use in your problem. Fingers crossed for you.